Good morning students. Today we will see HDL programming. So VHDL stands for Very High Speed Integrated Circuit Hardware Description Language. It is a programming language used to model a digital system by data flow, behavioral and structural style of modeling. In VHDL, an entity is used to describe a hardware model. It can be described entity declaration, architecture, configuration, package declaration, package body. So, we will see how we can perform the program using data flow or behavioral structural. Before seeing that, I will explain what is the advantage of this VHDL. It supports various design methodologies like top-down approach and bottom-up approach. It provides flexible design language. It is allow better design management. It supports a multi-level abstraction. So now we will start this HDL programming for half adder. So half adder, we will open this Xilinx software, select the file, new project, click new project, then you have to give the project name. Give project name and you can check this the project location where you are going to store this one, and then we are selecting the, you can see there are the top level source types are EDF, schematic and HDL. We are going to select HDL. Okay, then click next. Now you have to select the properties. What are the family, what are the device type and the package. Okay, the family is Spartan 3 and devices XC3 S4 400, and we have to select the package. Okay, TQ 144, and what is the speed. Okay, we have to select the 4. Then you have to enable enhance the design summary, message filtering and display incremental messages, and similarly which language, whether the ISC simulator, VHDL language, you have to select all these simulators and click next. Now you have to give source file. Now when you click this, you can whatever the types you have selected the device properties, no, you can verify it again whether we select the proper device family and device what is the package and speed. Okay, once if you verify it, you can click finish. Next you have to create a new source. You click the create new source. There you have to select Verilog module. Okay, Verilog module, and again you have to give file name. The first one where you have to store your program. Now you have to give them what is the program you are going to do. Okay, then click next. Then you have to select the port, that is input. So for half adder you require 2 inputs. Okay, so I am giving A, B input, and the output is also 2, right? Output is sum and carry. So I have to select output. Output is sum and carry. So now we have selected output, sum and carry. Okay, next we can verify it whether we have the input is 2 inputs are selected and outputs are 2, that is sum and carry. Finish it. Now you have to select we have to give them input A, input B, and output is S. What is S? S is sum. Okay, output C, C is a carry. Now you have to enter, you have to assign your what is sum. Sum is nothing but A exclusive or B. So I am assigning S is equal to A exclusive or, that is a cap, B. This is means sum. Sum is nothing but for half adder, sum is A exclusive or B, and similarly carry, you have to assign carry. What is carry for half adder? A and B. Okay, now you have to write the end model is there in the program itself. Okay, save it, select the synthesis, click that. There we have to check the if we have done any mistake in this by using this syntax error. Okay, check the syntax. If the green is visible, then there is no error in the programming. And again, you have to synthesize now. Again, you have to get green, otherwise you have to verify if there is any bug in the system. So you can see this. So everything is green, you tick green. So now you can select the behavioral model, create a new source. There you have to select, because we have to verify the output by in terms of waveform. So I will select a bench waveform. Okay, and again you have to give file name, half adder. Okay, next, finished. So here the clock information, whether you have to give a single clock, multiple clock, or we are using combination. So I have selected combinational. Finish. Now you can see this A, B is the input and S and C is the output. Now we have to give the inputs. Okay, input you have to select through waveform. Okay, whether you want to give 1 or 0, right? A input, similarly you have to select B input, whether you want to give 0, 1, 0, right? Now we will see the, save this. So inputted allotted. Now we have to execute it, right? Select hierarchy, our file, select the simulator. There you have to simulate the behavioral model. Simulator. You can see your output now. Okay, so now you can see here, I'll add a marker to check this. Now let us see this. A is equal to 0, A is equal to 0 and B is equal to 0. What is your sum? Sum is also 0, the carry is also 0. Now you will see here A is equal to 1, B is equal to 0. So both the inputs, both the inputs are different. Okay, 1, 0. So your sum is 1 and carry is 0. Now we will see both the inputs are 1. Okay, both the inputs are 1. See, both the inputs are 1. You can see that sum is 0 and carry is 1. Okay. If all 0, then your sum is also 0, your carry is also 0. Okay. So that's all about this half adder. You can also try using this Xilinx software. Thank you.